client of our project is Scaris Company, which is a major player on security market in Russia. Lately, thermal images equipment is getting more available for regular users and private companies. Thermal imagers can be used in a variety of different situations, starting with when it's nighttime and finishing with coal mining in underground fields when there is no sunlight. The tasks related to providing security also have a noticeable impact.
Our goal is to develop a programming product that will be capable to automatically detection humans and thermal images in real-time mode. Our software is going to be used in polarized scenarios in order to prevent accidents and casualties.
The project is focused on industrial usage cases. The resultant system should be installed on large trucks for transporting heavy loads, which are used at the remote areas of Siberia and Middle Asia, at oil-producing and processing facilities, container yards, steelmaking plants. Most of these facilities are located in the remote northern areas with long dark winters and bad rainy snowy weather conditions. This leads to reduced visibility for drivers, killing and injuring people on the road which are not detected on time. Our solution will signal to the driver, "Attention, people on the road," to prevent serious traffic incidents of that kind. We can draw attention to the following three key challenges in our work. Firstly, the different thermal cameras in different environments provide totally different pictures with different kinds of image artifacts, such as noise, blur, etc. Secondly, our solution have to work in real time and has strong complexity restrictions. Thirdly, standard metrics which are used for efficiency estimation of the detection algorithms are not suitable for our cases.
We are going to review all existing methods of human detection in their implementations, analyze their efficiency and modify them considering given requirements.
Project model and plan. In our university, we traditionally use Agile or Kanban software development lifecycle and tools, board in Trello. The lifecycle consists of 7 iterations or sprints from September to April. Every Agile iteration includes 7 iterations. Each iteration lasts 4 weeks. At every iteration, the team focuses on 3 things: development functionality, integration and testing at the end of iteration, and new release to the customer if possible. Week 0 of every iteration starts with evaluation of results of N-1 iteration. We redefine the goals and select efficient team members for current iteration for each task. Then we set up Trello cards and start off R&D activities. Week 1 and 2 focus on deep immersion of the project tasks and functionality development. At the end of week 3, we have to finalize the current results and get feedback from the customer. We make code review and finalize tests and our documentation. Team structure and roles. Our R&D team consists of a faculty advisor, 3 student researchers, and a student programmer. The team has an online conference twice a week and creates 1 detailed report a month describing the current result to the Institute faculty and project office. So it is important to submit our activities, results, and achievements on time and regularly. Online mechanisms of project management include Kanban-based Task Traveler Trello, Trello.com, CI/CD tools of GIT, installation or configuration in progress, and MIEM, high-level project tracker and results visualizing system. Participants meet once a week where we present the current results, get feedback and quality control from a faculty advisor. Online conferences still continue regularly. Besides, our team makes a report weekly on our development cycle.
Our solution is organized accordingly to the following architecture. We use a set of common computer vision and machine learning algorithms, as well as self-developed methods. The input of our program is an infrared image or video frame, and the output is contours that appears to be humans. So, on the first stage of the algorithms, we are trying to get all regions which potentially can be human beings by simultaneously using several methods, including self-made algorithm of symmetry finding and classic methods, such as modified Otsu algorithm and Kenny filter. Thus, we are forming complex filter. On the second stage, we applied post-processing to all regions to remove insignificant ones. On the third stage, we get some features from remaining regions and feed it to classificator, which can be neural network, for example. And on the final fourth stage, we perform classification and decide which of the detected regions should be considered as humans. So, we get our detected humans, and then that information can be passed to an operator or automatic system.
We consider several use cases. Our program either can be integrated as a part of a complex automatic system, such as a self-driving car and security system, or can interact directly and the user, such as a safety manager or a driver. After the last report, we created a metric that helped us with correct evaluation of the results. A special visual environment was implemented for this. It simplifies the markup process and helps to obtain a dataset. We need this information to train decision trees that helped us have clear answer if an object was found. We also tried a completely different approach to people detection. One of our developers implemented an end-to-end convolutional neural network that would detect people. And you can observe an example of neural network working with FLIR dataset on your screens. The result seemed interesting for our team, and we plan to continue research in this area.
The main hardware platforms we are aiming to use our algorithm on are Dell Embedded Books and Dell OptiFlex, which runs on Ubuntu Core and Windows 10 IoT operating systems. To reach our goals, we use two kinds of programming languages. The first one is Python, and the second one is C and C++ programming languages. We use Python for fast prototyping and experimenting, and we use C and C++ programming languages for production, which eventually gives us better performance. For working with Python, we use Jupyter Notebook and PyCharm integrated developer environments. For working with C and C++ programming languages, we use Visual Studio.